All right, today we're going to talk about finding equivalent proportions or equivalent ratios using proportions and word problems. So the first one is our equivalent ratios. Okay, so we have three different ways we can find them. Okay, so the first way we're going to look at this first one right here. The first way is to multiply or divide the term. So what you're doing is you're looking for a relationship. So between 3 and 24, I can go from 3 to 24 by multiplying by 8. And I can go from 7 to 56 by also multiplying by 8. So these ones have a multiplicative relationship because you can multiply by 8 to get there. Okay. Also, looking at the ones at the bottom, it's the same too. What we can do is we can go from the big number to the small number. And this time we wouldn't be multiplying by 8. What we would be doing is dividing by 8. So we're going to say that we're going to divide by 8 for those two. Okay, so in our text box here, we're going to write a little description for ourselves. So we're going to say we are going to look for a relationship where we can multiply or divide. Okay, and I'm going to make my font just a little bit smaller so that it all fits in there. So we're going to look for a relationship where we can multiply or divide. So that is how we multiply or divide our terms. So that's how we find one relationship or one equivalent ratio. Okay. A second way we can tell if ratios are equivalent is by using something called cross products. So when we use something called cross products, what we do is we're going to cross these two and cross these two. And what has to happen is that these both have to equal the exact same thing. So 9 times 8, we know, is 72. And 6 times 12 is also 72. So because these equal the same thing, that means we do have two equivalent ratios. So what we do is we multiply cross or diagonally to see if we get the same product. And if we do, then we know that they are equivalent. So if we try the one at the bottom here, we're going to do the same thing. So we're going to circle these two and circle these two. So 10 times 12 is 120. And 8 times 15, I'm going to write it on the side here, 15 times 8. 5 times 8 is 40. 8 times 1 is 8, plus 4 is 12, so 120 as well. So that means that one is also equivalent. Okay. The last one we have here is what we call reducing our ratio. So what we can do is we can break our ratio down instead of using the big one. So we kind of think of our ratio as a fraction like we talked about earlier this week. So what I'm going to do is 12 and 30. They're both divisible by one number. The greatest number is 6. So what I'm going to do is I'm going to divide both of these by 6. Okay, so 12 divided by 6 is 2, and 30 divided by 6 is 5. So I simplified this to 2 to 5. Okay, and now I'm going to try to do the same thing with 8 and 20. So 8 and 20 can both be divided by 4. So I'm going to divide by 4 on both of these. So 8 divided by 4 is 2, and 20 divided by 4 is 5. So again, we got the same answer, so that means that those two are actually equivalent once we reduce them. So we're going to reduce them with the greatest common factor, GCF, just like a fraction. And let's make that a little, so we're going to reduce it with the GCF just like we do with a fraction. Okay, so if we look at 6 and 10 down here, 6 and 10 are both divisible by 2. That's their greatest common factor, so we're going to divide by 2. Okay, so 6 divided by 2 is 3. 10 divided by 2 is 5. And 27 and 45, what is their greatest common factor? What are we going to divide by? Think we're going to divide by 9 is their greatest common factor. So 27 divided by 9 is 3, and 45 divided by 9 is 5. So 3 to 5 and 3 to 5. So that means that those two are, in fact, equivalent. All right, now it's asking us to find if these ratios are equivalent or not, equal or not. So what we're going to do is we're going to look for those relationships. And if we can't find any of them, then we're going to have to use the cross products and see if they're actually equivalent. But the easiest way is to look for those relationships, either dividing them and simplifying them or multiplying them together. So if I look at 9 and 27, how can I get from 9 to 27? Well, isn't 9 times 3 27? So I'm going to check down here. Is 12 times 3 36? And it is, so that means that that one is equivalent. So I'm going to drag an equal sign over here. Okay, looking at our next one here. Okay, I have 9 and 15 and 16 and 20. Don't think I can do anything with these. I don't see any multiplying or dividing across. Let's see if I can simplify these. So 9 and 15 can both be divided by 3. So 9 divided by 3 would be 3, and 15 divided by 3 would be 5. So I simplified that to 3/5. 16 and 20 are both divisible by 4. So 16 divided by 4 is 4, and 20 divided by 4 is 5. Are 3/5 and 4/5 equal? Nope. So that's not going to work. Another way I could have checked that was also by using the cross products like I did up top. Okay, if we couldn't simplify it, we would have had to use those cross products. Okay, we're going to go up here to 2/3 and 4/6. So looking at 2/3 and 4/6. Okay, there's two ways I could do this. One would be to simplify 4/6. So and the other would be to find our relationship. So 2 times what is 4? Well, 2 times 2 is 4, and 3 times 2 is 6. So that means that those are, in fact, equal. Okay. All right, we also have this last one down here. Okay, 22 and 55, and then 16 to 40. So what I'm going to do is I'm going to simplify. So if I have 22 and 55, those are both divisible by 11. So we're going to divide by 11, divide by 11. So 22 divided by 11 is 2. 55 divided by 11 is 5. So we have 2 to 5. And 16 and 40, they're both divisible by 4. They're also both divisible by 8, so we're going to use 8. So we're going to divide by 8. So 16 divided by 8 is 2, and 40 divided by 8 is 5. So we have 2 to 5 and 2 to 5. So that means that those are, in fact, equal. So we only had one that was not equal, and the rest were equal. Okay, now what we have here is it says the ratio of girls to boys in the junior high band is 3 to 4. Which of these shows possible numbers of girls and boys in the band? Okay, so what we're going to have to do is we're going to have to start with what we know. So we know that there's 3 girls, because girls is listed first and 3 is listed first. So 3 girls to every 4 is the second number, and the second number goes to boys. So 3 girls to 4 boys. Okay, so we're going to look at A. So A says 30 girls. So if there's 30 girls, that means we'd have to do 3 times 10 to get to 30. So 4 times 10 would be 40, but that says 44, so that's not going to work. Okay. B says 27 to 36. So to get from 3 to 27, what I'm going to have to do is 3 times 9. So 3 times 9 is 27, and 4 times 9 is 36. So that one is our answer, is B. Okay, so we are all done with that first slide. So now we're going to go to the word problems, which are very similar to doing this.